Hi, my name is Abraham Moscoso. I'm going to talk about tumor regression and allograft rejection after administration of anti-PD-1. First, we will see a video.
Of trying to As a scientist, I specialize in cancer immunotherapy. My work, and that of my colleagues, is to figure out ways to stimulate the immune system to kill cancer. To understand this concept, let's talk a little more about our immune system and how it works. Taking a look inside our body, all of us are born with an immune system that acts like the security checkpoint at the airport. Our immune system is like a high-tech, full-body scanner system that protects us from things that are harmful. In the immune system, T cells have receptors that scan cells to distinguish between normal cells and abnormal cells, like virus-infected cells. Once detected, abnormal cells are attacked and removed by T cells. T cells also identify these cells for future recognition. The same T cells also play an important role in protecting us from cancer. Cancer cells are normal cells that have mutated. The more mutations cancer cells have, the more easily they are detected. Until recently, we didn't understand why T cells were detecting these cancer cells, but not destroying them. But on a closer look, we've made some revealing discoveries. We've learned that one of the ways that cancer cells get past the security system is with the help of a molecule called PD-1 that is found on the surface of cancer cells. PD-1 is almost like a disguise that allows cancer cells to remain undetected. PD-1 basically hacks the T-cell scanning system by jamming the signal to parts of the T-cell system called PD-1 and B7-1. Think of PD-1 as a sensor that's part of the T-cell scanning system, and B7-1 is like an alarm that issues an alert when something is wrong. When PD-1 hacks the system, it prevents it from doing what it's supposed to do. In other words, it may prevent T cells from destroying cancer cells. Scientists have been working on fixing this problem and have designed molecules to target the PD-1 pathway. You can think of cancer immunotherapy as kind of like a software update for your immune system. Early studies suggest that by targeting the PD-1 pathway, T cells may be able to detect and destroy cancer cells. Let me show you in more detail. T cells have receptors that allow them to recognize cancer. Cancer cells can prevent elimination by turning on PD-1. PD-1 deactivates T cells by binding to PD-1 and B7-1. Blocking PD-1 from binding to PD-1 and B7-1 could prevent PD-1 from communicating with them. When this happens, T cells may finally be able to respond and kill cancer cells. Clinical trials are currently underway to understand the effects of trying to block the PD-1 pathway in the body. We are committed to studying cancer immunotherapy so that we can continue to find new ways to harness the immune system to
The definition: although antibodies against the programmed death-1 PD-1 receptor and one of its ligands PD-1 have produced tumor regression in multiple cancer types, these therapies are untested in patients treated with long-term immunosuppressive medications. This is a case in which PD-1 antibody was administered to a solid organ transplant recipient with a metastatic cutaneous squamous cell carcinoma. The patient had a robust anti-tumor response along with allograft rejection. This case suggests that anti-PD-1 can be highly effective against cancer arising in the context of chronic immunosuppression. It also suggests that PD-1 pathway may be critical in maintaining the partial tolerance that prevents T-cell mediated allograft rejection. We will see another video.
The role of the immune system is to protect the body from foreign invaders. Normally, the immune system responds to tumor cells as it does to any foreign invader, by destroying them. T cells play a central role in this immune response to cancer. T cells are primed and activated by dendritic cells within the lymph nodes. They can then infiltrate the tumour microenvironment, which is comprised of tumour cells and other tumour-infiltrating immune cells. Here, the activated T cells detect, bind to, and kill tumour cells. Programmed death ligand 1, or PD-1, is one of the inhibitory ligands that, under normal conditions, help maintain immune homeostasis. However, in many cancers, PD-1 can help tumour cells evade the immune system, particularly when it is expressed in abundance. This occurs when activated T cells release interferon gamma, leading to overexpression of PD-1 on both tumour-infiltrating immune cells and tumour cells. PD-1 interferes with the body's anti-cancer immune response by binding to its receptors B7-1 and PD-1 on the surface of activated T cells, thereby deactivating the T cell's cytotoxic activity. T cells can also become deactivated when PD-1 expressed on tumour-infiltrating immune cells binds to B7-1 or PD-1.
Applications in medicine. A 57-year-old woman underwent kidney transplantation from a deceased donor in 1989. She received standard long-term immunosuppression, including cyclosporine and prednisone. She presented with metastatic cutaneous squamous cell carcinoma in March 2014. Kidney function remained stable after reduction of immunosuppression to 5 milligrams of prednisone daily. Percutaneous squamous cell carcinoma progressed first during cetuximab therapy and then during tremetinib therapy. Her tumor contained a loss-of-function mutation in NF1. Administration of anti-PD-1 was then considered on the basis of her poor candidacy for cytotoxic chemotherapy. We'll see another video.
Well, I think as a scientist, you always hope that something that you discover will make a difference, never really knowing whether that will be the case or not.
Immunology has really promised to cure cancer for 100 years, but you couldn't go into your doctor's office and get an immunotherapy. CTLA-4 opened the door, and now PD-1 has really kicked the door wide open. Well, we identified the PD-1 ligand pathway, which turns out to be the major way that cancer turns off the immune response.
Dr. Hangzhou actually first cloned the PD-1. And then Gordon Freeman and Arlene Sharp, they actually helping identify how PD-1 binds to PD-L1, which we cloned it. We independently work on receptor and ligand, but we don't know this tool is relevant. Okay. Then Gordon Freeman and Arlene Sharp actually linked them together.
Well, our collaboration all started with a molecule called B7.
Gordon would clone the molecule and say, let's see how important it is. If we eliminate it from the immune system, does anything change?
Identifying the receptor-ligand interaction is like seeing a lock and a key relationship. And what we learned is this identifies the drug target, and it lets us then make a drug that keeps the key from inserting in the lock.
And we now appreciate that the tumor microenvironment has many layers of immunosuppression, and this pathway is a key mediator of these inhibitory signals, and that if you release that brake, then those T cells can enter the tumor and kill it.
When I was a student, actually, we learned from textbook talking about immune system is unlikely going to cure large tumor, especially late stage metastatic cancers. Now it's not true anymore. I think a textbook need to be rewritten.
You know, I do a lot of teaching of medical students, and I give a lecture on tumor immunotherapy. Early on, it was all of this hypothetical, and then it was with great joy that I had to rip up my lecture notes and start over, because now there are actually concrete examples of success.
This is transformative. This is the best thing going. 10 years ago, if you asked a pharma company to develop an immunotherapy, they would have been really resistant. And the Cancer Research Institute has played such an important role in funding this generation of work, which has led to where we are now.
Pros and cons. Pros. Advances in cellular and molecular immunology provide enormous insight into the interplay between the tumors and immune cells. Cons. The exams are expensive. We'll see another video. Conclusion. Anti-PD-1 can be highly effective against cancers arising in the context of chronic immunosuppression. It also suggests that the PD-1 pathway may be critical in maintaining the partial tolerance that prevents T cells-mediated allograft rejection. Thank you so much.